In this video, we're going to continue our exploration of multiplying and dividing algebraic fractions. We're going to look at slightly more complicated ones in this video, with more than one term in either the numerator or the denominator. But first of all, let's remind ourselves of how to deal with ones that we saw in the previous video. So here we have 11 over 9x squared y divided by 77y over 15x. The first thing we do when it's a division is copy the first fraction, change the sign to a times, and flip the second fraction to give us a multiplication that we can work with. Now we have to cancel terms that we can cancel. So we have 11 on the top and a 77 on the bottom, which cancels to 1 and 7. The 9 and 15, 3 goes into both of those, so the 9 cancels down to 3 and the 15 cancels down to 5. The x on the top cancels with one of the x's on the bottom, and that leaves us with 5 on the top over 3x y squared on the bottom. So to multiply and divide algebraic fractions with more than one term in the numerator or denominator, we're first going to factorize the expressions, much like when we were simplifying algebraic fractions. And then any common factors we will then be able to cancel. So let's look at some examples. Here we have x plus 4 over x minus 3 times 3x minus 9 over 5x plus 20. So the first thing we're going to do is factorize what we can factorize. Now the first fraction, x plus 4 over x minus 3, we can't factorize anything there. But in the second fraction, we can factorize the numerator to 3x minus 3 and the denominator to 5x plus 4. Now we've got an x plus 4 on the top and an x plus 4 on the bottom, so we can cancel those. And we have an x minus 3 on the bottom and an x minus 3 on the top, so we can cancel those, giving us a final answer of just 3/5. In this example, we're once again going to factorize what we can factorize. So we start off with a plus b, we cannot do anything with that, and 3ab is a single term, so we don't do anything with that either. Multiplied by 6a squared, again, can't do anything with that, but 2a plus 2b we can factorize to 2 brackets a plus b. Now we can cancel out an a plus b on the top and an a plus b on the bottom. We can also cancel out an a on the bottom with one of the a's on the top, and we can also cancel the 3 and the 2 multiplied together to give 6, which will cancel out with that 6 on the top. Putting that all together gives us a final answer of a on the top and just b on the bottom. In this third example, there's a bit more factorizing we can do, and it's also a division. So the first thing we're going to do is deal with the divide sign. So for a division, remember, we keep the first fraction as it is. We change the sign to a times, and we flip the second fraction to get 3p minus 9q over p squared q. Now we're going to factorize, and we get pq on the top over, we can take out a 2 there to get 2p minus 3q times by, and on the top we get 3 brackets p minus 3q over p squared q. Now we can start cancelling. We have a p on the top, which we can cancel with one of the p's on the bottom. We have a q on the top, which we can cancel with the q on the bottom. We have a p minus 3q there on the bottom, which we can cancel with the p minus 3q on the top. And that gives us a final answer of 3 on the top, and on the bottom we have 2p. We have another example now. We're going to do exactly the same thing. First of all, we're going to factorise what we can factorise. X squared y over 2x minus y. We can't do anything with that. Multiplied by 6x minus 3y. We can do something with that though. We can factorise that to 2x minus y. And all that is over x y squared. Now we're going to cancel what we can cancel. First of all, we have a 2x minus y on the bottom and a 2x minus y in brackets up on the top. We have an x squared on the top and an x on the bottom, so the x can cancel with one of those x squareds. And we have a y on the top that cancels with one of the y's on the bottom. And that gives us a final answer of 3x on the top over y as the denominator. Now this final example is a little bit more tricky. It has quadratics involved in it. But we deal with it in exactly the same way. So we start off with the fact that it's a division, turning it into a multiplication. So x squared minus 4 over x squared plus 4x minus 32 times by 5x plus 40 over x squared minus 5x plus 6. Now we need to factorise all the expressions in this fraction. On the top there, x squared minus 4 is the difference of two squares, so that's going to give us x minus 2, x plus 2, and on the bottom we're going to get, we want two numbers that multiply to make minus 32 and add to give plus 4, and that's going to be plus 8 and minus 4. In the second fraction here, we're going to get 5x plus 40, but that can be factorised to 5x plus 8. And on the bottom we have x squared minus 5x plus 6, so we're looking for two numbers that multiply to give plus 6 and add to give minus 5, and that's going to be minus 3 and minus 2. Now we're looking to cancel things that are on the top and the bottom. Well, first of all we have an x minus 2 here, and we have an x minus 2 on the bottom. We also have an x plus 8 on the top and an x plus 8 on the bottom. None of the other factors are on both the top and the bottom, so all there is left to do now is to put it all together, and we get 5x plus 2 over x minus 4, x minus 3. And that is our final answer. We could expand those brackets if we want to, but we don't need to. We can leave it in factorised form. So that's how we deal with multiplying and dividing algebraic fractions that have more than one term in the numerator or the denominator. First of all we factorise, and then we cancel out any common factors.